Hello again, everybody. Today we're going to talk about processes in Linux. In the Linux operating system, there are what are called processes. These are very, very similar to what Windows calls services. They're little programs that are running in the background that provide support for the operating system while it does what it's supposed to do. So let's take a closer look at what these actually are, what they do, and how they do it. First of all, let's talk about the difference between a program and a process. These are very, very tightly connected. A program is a set of commands that is stored in a file. This file is generally stored on your hard disk somewhere, and what this program does is it creates a process. It is what's called static. It is sitting on your hard drive in a file, but it is not operating yet. It's a static piece of code. The program is then loaded into the RAM, the random access memory of the computer, and it at that point becomes dynamic. It is an actively executing process. At this point, it is no longer just a file on a hard disk. It is active in RAM and it is executing. And we will talk about this in a little more detail coming up. There are two types of processes. The first type of process is the user process. These are processes that are started by a user on a terminal. Now, in Linux, processes are always started on a terminal. You can't really start a process using the GUI in Linux. It's always run from a terminal. The second type of process is what's called a daemon process. This name originally came from daemon way back because transparent to the user, they were just started by the system and the user didn't know where they came from, so it just kind of got the nickname over the years of daemon process. These are processes, like I said, that are started by the system. They are not associated with any particular terminals, and when you do various commands to see what's running, the terminal will display a question mark at this point in time, because none of these processes are associated with the terminal. They're just basically support for the operating system to service the users that are using the system at that time. Process family. Now this you have to think about a little bit. Processes are kind of organized with a family tree type of a deal. Processes do not spontaneously start. A process must be started by another process that's already running. The new process is called a child process, and the process that started it is called the parent process. So we have the initial process, which we're going to get to in a minute. It's called the init or initiating process. We have child processes and we have parent processes. The parent processes start the child processes. The process ID is a unique number that's given to a process that's running, and these are assigned by the operating system. There are two types of process IDs we're going to look at. One is called the PID, and it just stands for Process Identification Number, and it's a unique identifier assigned to any particular process. The PPID, on the other hand, is the Parent Process Identifier, and that is the process identifier of any process's parent. Like I said, any process except the init process will always have a parent. And the processes are linked to their parents, and that is the PPID, or the Parent Process Identifier. We see here a little tree structure representation of parent and child processes. Let's say, for example, this right here is process number 1. It's got a process ID of 134, and its parent in this case would have a process ID of 56 right here. It begins process number 2 and process number 3. You see here that process number 2 has a PID or process ID of 291, and its sibling, so to speak here, has a PID of 348. Both of these have the same PPID, or parent process ID, of 134 here and 134 here, which corresponds to the PID of 134 right here. Process number 2 spins off 2 more processes, number 4 and number 5. They have process IDs of 448 and 571. But again, notice the PIDs are 291 for both of these because they were both started by process 291. Initialization. The Linux kernel, which is loaded by the Linux bootloader when you initially boot a Linux system, will always have a PID of 0. This PID of 0 is the kernel, and it's starting what they call the init, or initialization daemon process. The Linux kernel always has a PID of 0. It is the only process that does have a PID of 0 with no parent processes. The init daemon always has a PID of 1, and that again is assigned by the operating system. The init daemon always has a PPID of 0 because it is always started by the Linux kernel. The init daemon starts all other daemons required for whichever run level you choose your system to boot up into. Let's take a look at a little bit of the genealogy process. You have the initialization daemon here, and it starts other daemons. And daemons, like I said, they're required for the system to be up and running. One of these daemons will then start the user login, okay, and that's in your configuration file as to which shell you run, what the account is, etc., etc. The user login then starts the bash shell. The bash shell will then start the user processes, okay? This would be the login and any processes that are being executed by that user shell of that particular user. Notice that the bash shell is started by the user login, which is started by a daemon. So daemons, or daemon processes to be a little more exact, always start the user processes. PS-tree is a utility that we use to view the family tree of processes. So let's go ahead and see what that would look like on this particular computer. Okay, I have Linux. Skip that. So now I have Linux Mint up and running. Okay, what I will do is we will open up a terminal, and we will maximize the terminal. I will then type in the command ps-tree. And we see here, this is a tree diagram of all of what's running. You see here the init daemon process, and that started the modem manager, it started the network manager, it started the accounts manager right here, it started the printer cups, which is basically a print server program. Here's the genome keyring manager. Now let's come down here because this is interesting right here. This is the mdmx.org. These are all the files here that have to do with the graphical user interface. And you see on this system, as we already know, we're running the Cinnamon desktop. And this is an example of how the desktop and the operating system are really two different things. Because you could have the GNOME desktop here, you could have any of the different desktops you want. But because this is the Linux Mint with the Cinnamon desktop, you see all your Cinnamon files over here. Okay, you see here some of the system D, which is used in startup. So this is a good way to see exactly what we're running. So now we're back to our PowerPoint, and we saw how to use the ps-tree command to see which processes are actually running in Linux. Where these files are stored that are the processes after they're loaded into memory and executed is the proc directory, or more specifically the /proc directory, the slash we need so that we know its position relative to root, because remember the root is up here. Processes are listed as files in the /proc directory. The processes are identified in the proc directory by their PID. When a process is created, it appears in the /proc directory. When a process is killed or naturally terminates or ceases to run, it is removed from the /proc directory. What that does is it basically means that the /proc directory is always changing. And because of that, it's known in Linux as the only dynamic directory. It's dynamic because it's changing. And it's the only directory in Linux that actually changes by itself. That's why we call it the only dynamic Linux directory. During system shutdown, all of the processes are removed from the /proc directory so that the proc directory is actually empty at the moment the Linux system shuts down. So now that we've taken a look at some of the properties of the /proc directory, let's go back to the computer and take a look at some of what's in the proc directory in an actual running Linux machine. To do this, we'll be at a Linux terminal and we'll enter the ls for list and we'll type in the /proc command. And we hit enter. And here you see all of what's running here. You see the PID, you see the size, you see the file names. Now all of these in white here are system files. And this is really good because you could get some really good information, like right here, CPU info. If we want to get information about that, we could type in cat/proc/CPU info. And you see this gives us all kinds of information about the CPU. So some of these are really good to know how to use. Going back to the listing of our proc directory. Okay, they also have device information, disk statistics, buddy info, memory info, as we said, what's mounted right here, uptime, version. There's a whole bunch of these files that are all running processes that contain good information. So let's go back to our PowerPoint. So that shows you some of the actual files on a real Linux machine of what's in the PROC directory. Thank you for watching, everybody, and I'll see you on the next process video.